Got Todd. Yeah, I recognize. Everybody's just joining, so we'll give it a few minutes for everyone to join. If you want to, let's should we do a where is everybody? So if you go on the chat, change it to say to everyone so everybody can read it. I am in London, like always, in my hospital looking room, as Alexi tells me. Where are you, Alexi?
In Amsterdam, not in a hospital.
Amsterdam. Oh man, we were boring. We were boring this time. We've done London and Amsterdam 2 in a row. Where is everybody else? We need somewhere else than London and Amsterdam. We've got another London. We've got a Ramazan. Hello again. Ramazan's always here.
Which city, by the way? You said Turkey, but I want precise answer.
It's not precise enough for Alexi.
Uh-huh.
Ankara. North of Spain, Adrian.
It is,
Nice.
again, a little bit imprecise. What does it mean, north of Spain?
Germany, but not Berlin.
Ah, you are so secretive today. Tell me the
I think we
exact.
were too precise. You should have been like, I don't know, the Netherlands somewhere.
Which part of London are you?
Me,
Okay.
I'm in the south of
Ah,
London.
okay.
Um, about 10 miles south. And then just inside central,
Central what?
okay, and then central London. Central London is good. That's a very big area as well. Nice and nice and vague. Cool. So we've got Europe covered. We've got no one from the US yet, or at least they are not volunteering.
There are absolutely people from the US on this
There
call,
are.
but again, they prefer to remain silent for some reason.
Tyler's Tyler. Tyler's in the US. Solitary US person. Cool. So
Hi, Alan. Nice to see you again.
should we get started then? So if you have any questions, just ask them on the chat. If you're on YouTube, ask it over there. I will be watching, and then, like what we usually do, we'll ask Alexi when there's a gap between slides. Cool.
Okay.
I can not see your slides yet. Now I can see them. There we go.
Okay, so this is ClickHouse release 25.5, spring summer release. There is a lot of features as usual, and I hope we will have some time for your questions. We have 15 new features, 23 performance optimizations, and 64 bug fixes. Let's start with some interesting, small and nice features like new functions or new settings. I like functions, I don't like settings, but let's take a look. The first is about two new functions to calculate entropy of bytes inside a string. So the first function is named string bytes unique. It returns the number of distinct values of bytes inside a string. So if it will be a string ABC, there are 3 different characters, so it will return 3. And another function, string bytes entropy. It is a bit more interesting. It calculates a Shannon entropy and a Shannon entropy of the distribution of bytes inside a string. And it returns how many bits on average is required to encode every byte of a string using a theoretically optimal code. So let's take a look at some examples. In the first example, we calculate entropy of a random string of quite a large size, 10 kilobyte of randomness, and we would like to see if this string is actually random. And if we calculate the entropy, it returns 7.9 98. That is very close to 8 bits per character. So we can conclude that the string is definitely random. But let's take a look at some more interesting examples that I prepared for you. Let me open ClickHouse local, which is available under this shortcut, ch. So you just type ch and it runs ClickHouse local. And let me find an example. So in the first example, I will take my SSH key, not my private key, but my public key. So this string is my SSH key. And I would like to know what is the number of distinct bytes, what is the entropy of my SSH key, etc. So the number of distinct bytes is 65 because it is in base 64 encoding plus some padding characters, which gives 65. If we calculate entropy, it will be 5.9 and something very close to 6. And as we know, base 64 has 6 bits per element, per digit, from 0 to 63. We can also take base 64 decode to get the binary representation of my key. And the binary representation has 220 different bytes, not 255, slightly less, but still it is quite random. And the entropy of this binary representation will be 7.5. So yes, this function definitely works. Nothing surprising. Let's go and see something else. But first, let me ask Mark. Mark, how would you use these new exciting functions?
That is a very tricky question. I do not know how I would use this one. What should I use it for?
Just take all the strings and calculate these numbers, and then just stare at these numbers and try to get to some conclusions. And maybe you will get some new philosophical observations about the world.
Robert says I should use it on all your passwords.
Yeah, it's a really good idea to check the passwords. How I would use this function, I would take some data from my database, like URLs, and I know that some parameters are not worth storing because they contain some encrypted data. I will filter these parameters and then decide to just filter it before storing in the database. Or another idea is to do it to mine some tokens that should not be stored in the database. Some secret tokens. Okay, another two functions for another encoding base 32. So base 32 is similar to base 64, but it uses only 32 different characters. The alphabet from A to Z and most of the numbers. Actually, not all the numbers, because then it will be not 32, but 36. Just a subset of numbers. There are actually different standards, different ways to do base 32. And what is implemented is corresponding to RFC, one of the most standardized options. And let's take a look at the example. Here is a string. ClickHouse is a good database, and yes, it is, because it has all these functions. It has a function base 32, base 64, and even base 58. All of them are used in different applications, mostly in the blockchains, in some social networks like Blue Sky. It uses base 32. And you can see that base 64 is the most compact. Base 58 is actually the same on this example. And base 32 is about probably 16% longer. You can encode, decode, etc. Nothing interesting. Okay, and this is way more interesting. The functions to calculate sparse grams. And now I have to take effort to explain very carefully what it is. First, there is a well-known n-gram algorithm to extract short tokens from a string, where n is some number like 3. If n equals to 3, it will be 3 gram. If n equals to 2, it will be b gram, etc. If we take some word like this, and extract character 3 grams, it will be all subsequences of length 3. Subsequences, continuous subsequences. So this one, that, then ETE, then TER, then ERM, etc., up to the end of the string. And this will be n grams. And we already have support for n grams for many years, for 5 years. And now we also have sparse grams. And sparse grams are extension to n grams that extracts all the n grams plus sometimes it extracts a subset of longer sequences. So in addition to 3 grams, in some cases, it will extract 4 grams. But the selection, which 4 gram or 5 gram or 6 gram it will extract, deterministically defined, so it will be some robust way to extract longer but rare substrings. Probably my explanation did not make it clearer, but let me show you a demo. Because it is really a nice algorithm, it is really elegant. If you already knew what is sparse grams, please comment in chat, because I would like to know how many of you already knew this. Probably 0, probably Mark. What about you?
No, never heard of it until I saw it on the slide.
That's great.
You're teaching everybody.
Yeah, I have a chance to explain it. So let me open some examples. And again, I will show it in ClickHouse local. Here we will just extract all 3 grams from this string. ClickHouse is a good database. And yeah, it is CKH, Bus, Ase. Okay, I will not pronounce all of this. It includes white spaces, by the way. So this is quite trivial. Now let's do this with sparse grams. And you can see that, yes, it has everything that n grams returned, but also sometimes pretty long substrings, like ClickHouse is a good whatever. ClickHouse is a good. Now let's look more deeply. First of all, what will be the length of returned array? For n grams, it's about the same as the string length minus 2 in this example. So if string length is 30, the number of n grams will be 3 grams will be 27. Or the string was 29 characters. Okay. But the number of sparse grams is a little bit bigger, about 2 times bigger. Now let's take a look if we select which sparse grams are longer than n grams, than 3 grams. We can see this. And some of them have length 4, some of them have length 6. Now let's look at the distribution of length. And we can see that it is about negatively proportional. Most of them have length 3, then just a few have length 4, slightly less 5, then 6, and the longest is just a single one of this long. And now let me show that we have yet another function named sparse gram hashes. And instead of returning substrings, it will return these 32-bit numbers that you can just store somewhere. And now I have a really interesting question for you. What is it for? Why do we need this?
Usually when I have no idea, you tell me that it's because another database has it that we integrate with.
No, and I doubt that any database has it.
Ramazan says similar code search on a large code base.
Exactly. Thank you, Ramazan. You saved me. It is not only for code search, it is for text search, but it is for kind of abstract text search. So the text can be unstructured, it can be not in a natural language, it can be not, it can be arbitrary sequences. And due to the fact that large sparse grams are rare, these large sparse grams represent tokens that will have a very high selectivity during the search. Oof, I hope I explained it. Now, another improvement, geometry types in Parket formats. Did you know that Parket files can contain binary data annotated as some geometry data types? And this binary data will be encoded with WKB format, which means well-known binary. So it is supposedly to be well-known. And since version 25.5, it is also well-known to ClickHouse, because ClickHouse recognizes these annotations and decodes this data into different types, automatically inferred, like point, line string, multi-line string, polygon, or multi-polygon. We have these data types in ClickHouse. Now we just added this inference for Parket. And again, let's take a look at some demo. ClickHouse local can work with external data sources. And here I will read from a public bucket in S3. The bucket is named FSQ places, and it contains a dataset from Foursquare, from the company Foursquare. First, let's do this query and take a look. I do it from my home, from my connection, network connection. So it could take some time, but it already finished. And we have some data about interesting places like Carson High School, located in Carson City, the phone number, website, etc., and a column named Geom with geographical coordinates. It works as expected, nothing unusual, nothing surprising. Now let's compare with the previous version. And here I have quite an old version, 24.12. And I will do the same query and you will tell me the difference. Actually, there is a lot of difference. The most noticeable is a difference in the output format. In the new version, it is automatically detected if it is a single record or just a few records. It can be printed like this, with a lot of columns. In the previous version, it is not so good. Now let's use the same format. And can you notice the difference? What is it? Where is the difference?
It's just binary, isn't it, on the geom?
Yeah, it's a binary. It
What
is
about
even.
the bounded box? I guess that wasn't a geometry type in the Parket.
Let's take a look. I will do describe, select.
You're missing a C.
Oh, yeah. Yeah, bbox is just a tuple. And geometry in the old version recognized it as just a nullable of string. In the new version, let's compare. Now it's a tuple of nullable, but actually it is a point. It should be a point. It is printed as a point, so don't worry, everything will work. And the box is a tuple of 4 elements. Okay, another interesting feature. And this is really nice. It is named implicit tables in ClickHouse local. It means that you don't have to write from a table. If you have just an input file, you don't even have to write select. You can just write a column name. You can filter, you can write where, you can sort with order, everything. You can just write what is inside select, but you don't have to write select or from. And what is interesting, now you can use ClickHouse local as a faster and richer replacement of JQ. So anything in JSON can be filtered, processed, analyzed with ClickHouse local. And again, a demo. I have a lot of demos today. And to show the demo, let me find some JSON file on my machine. And I will use the file named compile comments.json. It has 77 megabytes of data. It looks like this. Not a complex JSON, but we will analyze it. First of all, you can do this. If you want just a single field from JSON, write like this, ch query, and this field, and it works. Here are my CPP files. If I quit, it will tell me that I did not read all the result. It is okay. I can apply some functions for analysis, like this function will extract file extensions. Easy. Most of the files are CPP. Some third-party files are C. And finally, let's do some analysis. So this is a slightly wrong invocation. So most of the files are CPP. And if I want it even better, I just request output in the pretty format, and here is my pretty report. Another feature, if you do truncate all tables, now you can specify a clarification with like pattern. Now, what about data lakes? data lakes deserve a special category in my presentation because every release we have something new for data lakes. And the first improvement is support for partitions by buckets. If you use Spark, Apache Spark, or AWS Athena, or whatever else, Presto, Trino, probably you should use ClickHouse instead. But anyway, if you happen to create an iceberg table in Spark, you can specify partitioning by a bucket function. This is a function specific to iceberg. It uses specific algorithm to split different data with different data types by a certain number of buckets. It is just a hash function, but it is kind of a special hash function. And now we recognize this partitioning and use it for partition pruning. So if you do select query with a condition on partitioned field, the query will run probably 50, not 50, 30 or 40 times faster. And as a bonus, these hash functions are available as a functions if you want to analyze how the data is partitioned. You can invoke these functions separately as iceberg hash or iceberg bucket transform. Another new feature is the support for Hive Metastore catalog. I would just say that now ClickHouse has support for every data catalog that you ever needed. About half a year ago, we introduced REST catalog. 2 months ago, we introduced Unity and Glue, and now also Hive Metastore. And probably it is the least popular data catalog, and you should not use it, but anyway, there are feature requests, and now these feature requests are fulfilled. And yet another feature that is difficult to explain, support for version hint. If you have an iceberg table, it can contain multiple versions. We can say multiple snapshots. This can be used for time travel, so you can take a snapshot for yesterday or a week ago if you created this snapshot. And the question is how to choose the snapshot that you want to read. And by default, we will take a look at the metadata files and find the latest one. But if the data is currently updated, it is unclear which version we actually have to read. And for this purpose, iceberg writers may create a file named version hint.txt. I don't know why .txt, not txt. It looks strange, but anyway. And it will hint us which snapshot to read. And this is just one of the ways to select the snapshot for reading. There are also a way to specify explicitly a data path, a way to choose it by the time, or if you use data catalogs will define what to read. So it is quite an obscure feature, but someone needed it. Now about performance improvements. And the first improvement is for queries with final. If you used ClickHouse for a long time, you already know that ClickHouse can do data transformations in the background. You can create a table that will deduplicate data in the background, It is named replacing merge tree. Or you can create a materialized view that will do incremental aggregation. It will calculate summaries of your data in the background, so you can use it for faster queries. It is named aggregating merge tree. And if you do select query, by default, it just reads data that is not necessarily merged. But if you add a final modifier after the table name, the select query will do merge on read. And it will literally return you the final data. But there is one problem. How does it work with secondary indexes? So secondary indexes can skip some of data ranges from your data, but these data ranges may affect the values in your result if you applied merges. So it's like you ignore some subsets of your data, and this is not a good thing to do. And how to solve this problem? First of all, this problem is relevant not for all scenarios. Like if you have a primary key by user identifier and a secondary index by username. And you filter by usernames. And if you can assume that usernames never change, then it is safe to apply secondary indexes. If usernames can change, it is not safe because secondary index could skip one granular, and this granular can contain this update, the change of username. And we introduced a setting named use skip indexes if final that you can define to true when you assume that using indexes is safe. And it was available a long time ago. In the latest ClickHouse release 25.5, there is another setting, use skip indexes if final exact mode, which I recommend to enable by default, and it will be enabled by default soon. It does the following. It will read all the ranges that may contain updates to the data, to the filtered data. So it may lead to reading slightly more data, but the result will be guaranteed to be correct without any assumption. You don't have to do any assumption, just enable this setting and it will guarantee the correct result. And now let me show you, because again, it is difficult to explain. It is much better to show. Now I have a server with a data set. Let me connect with ClickHouse client, and the server is updated to 25.6. So even fresher than 25.5. And there is a table with a replacing merge tree named Hacker News History. Here it is. It contains ID, and ID is the primary key. Here we have order by ID. Yes, it is replacing merge tree, and more precisely replicated replacing merge tree. And I created a secondary index using column by, where it is the name of author, comment author of type Bloom filter. Now let's run some queries. First of all, I will disable query condition cache, another new feature that speeds up every query regardless of the existence of any indexes. It will automatically build indexes on the fly, but this time I don't need it. I want to show the difference without automatic indexes, only with these table indexes. So I disabled it, and I will do this query. Pradeep Chetri is my friend, it is my colleague who posted a few comments on Hacker News, so I will use his name to show the performance. The query is really fast. It's scanned 1.31 million records, and the total number of records 44 million. So the index works. Now let's do the same query with the final modifier. And it is slightly slower. So it was 19 milliseconds, and now it is about 10 times slower, 200 milliseconds. Actually, the difference is not noticeable. Every query is fast in ClickHouse, but what if I want it even faster than 200 milliseconds? By the way, the results are different because this query returned some duplicates and 143 records in total, and this query filtered out duplicates by merging them, and the result is 140. So yes, it is slower. Now let's tell ClickHouse to use skip indexes regardless if it will be correct. And the same query, it takes the same amount of time as without final as expected. Now let's enable the new setting. Use skip indexes if final exact mode. And do the same query. It reads slightly more records, 6 million. It takes slightly more time, 68 milliseconds, but it is faster than query without indexes. So we can see that indexes still work, and the result is guaranteed to be correct. And I would say that for this data set, we don't have to use this setting because I know that usernames do not change. So it is not necessarily. But for your data sets, it will have a lot of use. Okay, Mark, let me ask you, just in case.
Yeah.
Would you enjoy using this setting?
I have to say yes, don't I? Gotta be yes. Always good if it makes it faster.
Okay.
Orhan says, this is really awesome because we have performance problems with using final. So hopefully they will not be with this.
Okay, this is reassuring. Now something interesting. And the first is about correlated subqueries. You remember I introduced correlated subqueries last month in the previous version. And now we support even more correlated subqueries, more types of them. So let me remind what it is. Correlated subqueries are subqueries that reference columns from the outer query. So this column is from here, not from here. It likes subqueries that want to jump out of them. And typically you don't write these queries. And mostly correlated subqueries are long time forgotten. But they are used in some benchmarks, and we have to support these benchmarks. So in the previous version, 25.4, we introduced correlated subqueries with the case of where clause with the exists operator. In the new release, we also added support for scalar correlated subqueries. So something like select, select. Scalar correlated subqueries inside the where clause and correlated subqueries inside select. And now it is enough to pass and successfully run all the queries from TPC-H test suite without any modifications. Until recently, you had to rewrite queries manually. Now everything runs without rewrite. And another interesting feature is vector search. It is promoted from experimental to beta. So now it is safe to use. All the bugs were fixed, performance optimizations were made, and it is ready for you. So let me remind you about its history. Almost 3 years ago, it was introduced in experimental version by the research work of these 1, 2, 3, 4, 5, 6, 7 people. 7 people tested different data structures, different libraries, including phase, annoy, diskNN, HNSW, almost everything. And some of these libraries are added to ClickHouse. But it was just like a prototype. 2 years ago, we introduced, not we, but David Vardanyan introduced integration with the usearch library, which is probably the best implementation of HNSW algorithm available. It's like a graph algorithm to approximate search inside high-dimensional spaces. Just a few months ago, in 25.1, these indexes were significantly speed up with different optimizations. And now in 25.5, finally vector search is in beta. What does it mean beta? It means we fixed all that we wanted to fix, but still waiting for your results in your scenarios to optimize, to find corner cases, etc. And then it will be promoted to production. And the most important change in the latest release is support for filtering strategy. The filtering strategy can be set to post-filter or pre-filter or auto. And this determines how hybrid search will work. And hybrid search is when you filter by some indexes or by some columns, like you find similar pictures in your database, but also filter pictures by metadata. Like find me similar pictures, but shot on Canon DSLR. And it will do approximate nearest neighbor search. And not just extract like 100 of nearest values, but it will extract more to find values that find records with this metadata. And you can tune it on a per query level, so it works as it should. What about integrations? ClickPipes now supports not only S3, but also Azure Blob Storage. It is in private preview, so you can request this support and it will be enabled for you. ClickPipes will consume data from Azure Blob Storage in a streaming fashion. You just push data into Blob Storage and this data appears in your database. A couple of the updates for dbt, performance optimizations for Java client, and a lot of usability improvements for Grafana, including better support for traces. Now the bonus. The first one is especially interesting. If you did not see it before, I will just show it you right now. It is named AgentHouse or llmclickhouse.com. It is a way to make all language models smarter by plugging them to ClickHouse. So if, say, OpenAI GPT-4.5 or whatever was stupid, now it will be smart. If Claude was stupid, it will be smart. The only thing you need to do is connect it to ClickHouse using the ClickHouse MCP server. So let me open it and show you something. Here is AgentHouse. And let me try some query. It could be any query. I tried it today and it worked. But maybe we will experiment with you together with any other query. How has the ClickHouse popularity grown in 2025? It is thinking. It is quite polite to me. And it started to use ClickHouse. Like list databases, list tables. Here are tables from demo dataset. There is a Stack Overflow database with questions related to ClickHouse. It starts to run some queries against ClickHouse automatically. And another query from Stack Overflow. And then it decided to switch to GitHub because Stack Overflow is not interesting. And from GitHub, it does another query. And thanks to ClickHouse, all these queries are fast. It's only LLMs are slow sometimes. Okay, and we have some result. And I'm hurrying to see this result. It even creates an HTML page for me with some charts. Development activity peak. What it will be? Should I trust this result straight ahead or not? It even writes some JavaScript. I did not expect that many.
It's building a serious app for you here.
Yeah, so having
I-
had the opportunity to actually show this at a lot of places, the way I think about these agentic workloads more than anything is this is a business analyst on your team asking 11 million questions. They're just asking 11 million questions very quickly. And having a database that supports the response time like ClickHouse does makes it okay for the LLM to ask so many questions very quickly, right? It's happening at 5x, 10x, 30x the speed of a human, and ClickHouse supports that.
That's true. Thank you for explaining. But now let's see what is the answer. How the popularity has grown. And May is it's still about 20th of May. In April, it has grown compared to March. So it looks correct. I like it. And this is about pushes, about contribution. Wow. That's even more interesting. I can probably spend a day inside this tool asking different questions. And what is also interesting, You can take ClickHouse MCP server. It is open source. It is available for everyone, and it will work with your database. And soon we will also introduce this AgentHouse inside ClickHouse Cloud. So it will work with your organization. You can ask anything about your business data or whatever data. That's really amazing. Okay, and another bonus is visualizations on the map with ClickHouse. And there is an example with a data set of places of interest. Let's open it. And here it is, places of interest. So which is your favorite city? London? If I ask Mark, probably here it is London.
Ooh, where's that? Oh, there we go. Central
All this
London.
yeah. And all these visualizations are done on the fly using this query. So every time I scroll the map, every time I zoom in or zoom out, this query is run and it returns pixels. And pixels are rendered. Let me zoom in and generate a report. Did you see how a report is generated? You did not see because it has generated instantly, absolutely instantly. And we can slice and dice this data, like find interesting category, like bars in London, but there should be plenty, or hotels, offices, education, what
What does
else?
it do if you click on one of those?
Let's take a look. Buy kitchen product. Here is one shop with buy kitchen product, but probably more in London. Let's remove this buy kitchen product because I'm not interested in buy kitchen product, and switch to bars. What is dining and drinking bar?
Oh, there we go.
And all bar ones, Slug and I don't know, Mitchell and Butlers. Do you know Mitchell and Butlers? I don't. I'm not interested in this. But if you look at, for example, bars in Saudi Arabia, there are quite a few, but much less than in London. And all of them are Arabic for some reason. But interesting, if I go to, say, Japan and select different categories, the most popular category will be Japanese restaurant. You know, actually, there are a lot of different data sets, like a data set named birds, and it displays birds here, like this. And there is even more interesting data set named you, but I will not show it to you because it is a kind of sensitive data set. It is about you. Let me not show it to you. You have to see it by yourself. And another announcement. Next week, May 28, 29, we will host a conference, Open House. It's the first ClickHouse conference in San Francisco. I would like to see you there. I would like to meet you there. So please register if it is not too late. Maybe it is too late, I don't know, but please take a look. And I would like to see you on our meetups in Tokyo, Cyprus, in any of 3 meetups in the United States or in Tel Aviv. In our blog, you can find a lot of interesting articles, including an article about places visualization on the map, or an article about streaming change data capture from MySQL, or about ClickHouse usage by musical artists. Pretty interesting. And now 5 minutes for your questions.
Let me have a look. Don't know if we got any questions so far. You got some praise for the update to ClickHouse Local, saying it will eventually replace awk, JQ, and other shell scripting tools.
Maybe it will replace Perl. Maybe it will replace Bash.
All you need is ClickHouse.
Yeah.
She reminds me, one of our colleagues, Sean, wrote a blog post called "Don't Think, Use ClickHouse." I'm going to paste it on the chat.
That's a really good title.
He works on the same team with me, and we persuade him. He was originally using lots of different tools, and we're like, just use ClickHouse for that one, and for that, and for that. So I guess he was using it to do some analysis of a Git branch. Pretty cool.
Yeah, sometimes I say that there is ClickHouse way and there is a wrong way.
Can be nice though. You just if you know SQL, can take it and apply it to pretty much any data structure, right? Cool. Well, I guess no one is asking us any questions, so maybe we can give you a couple of minutes back.
Okay,
before the
see you
hour
next
is up.
time.
Cool.
Yeah,
See
indeed.
you,
Thank
everybody.
you so much, everyone. Greatly appreciate it. As always, feel free to go to clickhouse.com/Slack to join us in the Slack community. If you haven't started the repo on GitHub, you should, because you should be aware of all the amazing things that are going on. Everything that Alexei touched on in 25.5, there's even more in 25.6. Keep an eye out for the release blog that comes after this, that Mark and Tom and others do such an amazing job of writing that summarizes, and share your favorite features with people who should know about them. Cheers. Thank you so much, everyone. Be well.